Okay, let's go through some ACT questions. So this first question says only 10th, 11th, and 12th grade students attend Washington High School. The ratio of 10th graders is 86 to 255. So that's probably important. So 10th graders is 86 to 255. The ratio of 11th graders is 18 to 51. So 11th is 18 to 51. We don't know 12th. We could figure it out. If one student is chosen at random from the entire school, which grade is that student most likely to be in? Well, we can make percentages out of these, right? If we actually divide, so I'm just going to take my calculator and I'm going to divide 86 by 255. And I get 0.337, which is, I could just move that decimal over twice, so that's about 33.7%, right? We can do the same thing for this one. So 18 divided by 51, you get 0.323 if we round, so 353. So that's going to be about 35.3%. From that, we could figure out the percentage of 12th graders, right? Because if we only have 10th, 11th, and 12th graders, then the total population is 10th, 11th, and 12th graders, so this has to add up to be 100. So we could do 33.7 plus 35.3 plus the 12th graders, which we can call X, equals 100, because it needs to equal 100%, which really we're just doing 100 minus 33.7 minus 35.3, and we get about 31%. Okay. So that means the biggest class is 11th graders. So if you choose a random student, you are most likely to choose an 11th grader. Okay. Okay, 48. So this one, we just have to add that. So to do this, we have 4 over the square root of 2 plus 2 over the square root of 3. Which we just need to get a common denominator. So I'm going to multiply this first one by the square root of 3 over the square root of 3. And I'm going to multiply this one by the square root of 2 over the square root of 2. So this becomes 4 square roots of 3 over 3 times 2 is 6. And this is 2 square roots of 2 over the square root of 6. We have a common denominator there, so we can just make this one fraction, 4 square roots of 3 plus 2 square roots of 2 over the square root of 6, which is this one right here. And they didn't make you rationalize it. If they did want you to rationalize this, the next step would then be to multiply by the square root of 6 to top and bottom. But we don't need to do that because we don't care about rationalizing. Okay. Okay, this one right here. So this shaded region in the graph below represents the solution set to which of the following system of inequalities. So we want to figure out, well, which one of these is giving us this shaded region right here. And the easiest way to do this is to pick a point inside of that region and see which one of these holds true for these statements, which the easiest point is probably right there, 0, 0, right? 0, 0 is inside that region, so that means that these statements should hold true for 0, 0. So if I plug in 0 for like A, I get 0 is less than negative 0 plus 2, which is 0 is less than 2, that's true. This one, I have 0 minus 1, so that's negative 1 squared, which is 1, plus, you plug in 0 there, so that's negative 2 squared, so 4 is less than 9, which that says 5 is less than 9, which is true. So that means that A must be our correct answer. But let's just double check ourselves. So if we plug in 0 here, so 0 and 0, I get 0 is greater than 2, which is not true. So that one doesn't work. Same thing here. If I plug in 0, I get 0 is greater than 2. Again, doesn't work. This one, I get 0 is 0 and 0. is less than 2, which that's true. If I plug in 0 here, I'm going to end up getting 1 out of that. 0 in here, I end up getting 4 out of that. So that's saying 5 is greater than 9. That is not true. And then this last one, I would plug in 0, so I get negative 2 is less than 3, which is true. But if I plug in 0 here, I get negative 1 is greater than 3. That is not true. So then the answer here must be A. Okay? There's not a lot I want to reiterate from the video. I think the biggest thing is end behavior. So when we're talking about end behavior, if we're talking about end behavior of a polynomial, the biggest thing is to remember this chart. So we have our exponent, and it's the highest exponent, so I'll put highest, or the greatest exponent. And then we have our leading coefficient. Okay, so if we write this out, the exponent is either going to be even or it's going to be odd. And the leading coefficient is either going to be positive or negative. Okay, even means that they are going in the same direction. The ends are. And odd means they're going in opposite directions. So even, if it's even and positive, they're both going up. If it's even and negative, they're both going down. If it's odd and positive, it ends positive, which means it starts the other way. If it's odd and negative, it ends negative, which means it starts the other way. Okay, so if you're given f of x equals negative 3x to the 4th plus 7x to the 5th plus 9x minus 1. We want to look at the highest exponent power here, which would be this one. So this is odd, and it is positive. So odd and positive means that the graph is going to look like this. So we would say as x goes to negative infinity, f of x goes to negative infinity. And as x goes to infinity, f of x goes to infinity. Okay, if we did another one, so if you had f of x equals negative 3x to the 8th plus 7x to the 4th plus 9x cubed plus 4, we'd look at our highest exponent there. This is now even, and it is negative, which even and negative, that means they're both going down. So it's going to look something like this. And you would write as x goes to negative infinity, f of x goes to negative infinity, and as x goes to infinity, f of x goes to negative infinity. Okay. I'll be on Google Meets today, so if you have questions, please pop on. Okay, bye.